Hello everyone, I'm Siriji from Sri Venkateshwara College of Engineering, 6th SEM, Department of Computer Science and Engineering. I'm here to discuss about the topics Introduction to Non-Conventional Energy Sources, Classification of Energy Resource, Salient Features of Conventional and Non-Conventional Energy Resource, Solar Energy, Classification of Methods for Solar Energy Utilization, Merits, Demerits, and Application of Solar Energy, Photovoltaic or Solar Cell, Water Power, Wind Energy. Coming to introduction. A systematic study of various forms of energy and energy transformation is called energy science. While fossil fuels will be the main fuel for thermal power, there is a fear that they will get exhausted eventually in the next century. Therefore, other systems based on non-conventional and renewable sources are being tried by many countries. These are soil, wind, sea, geothermal, and biomass. Coming to classification of energy resource. Energy can be classified into several types based on the following criteria. Based on usability of energy, primary and secondary sources. Primary sources are those that are embodied in nature. Common primary energy sources are coal, oil, natural gas, sunlight, wind, and biomass such as wood. Other primary energy include nuclear energy from radioactive substance like uranium, etc. These resources generally available in raw form. These resources are extracted, processed, and converted to a form required by the consumer. Secondary resources are supplied directly to the consumer for utilization after one or more steps of transformation. Example, electrical energy and thermal energy. Based on long-term availability, renewable and non-renewable. Renewable sources which are obtained from sources are essentially inexhaustible. Examples, wind, solar, tidal, and geothermal, etc. Non-renewable sources which are finite do not get replenished after their consumption, or these sources are exhaustible, do not quickly replenish. Examples include fossil fuels, nuclear, etc. Salient features of non-conventional energy resource. Advantages. Non-conventional energy sources are available in nature free of cost. They cause no or very little pollution. Thus, by large, they are environmental friendly. They are inexhaustible. They have low gestation period. Disadvantages. Though available freely in nature, the cost of harnessing energy from non-conventional energy sources is high. As in general, these are available in dilute forms of energy. Uncertainty of availability. The energy flow depends on various natural phenomena beyond human control. Difficulty in transporting this form of energy. Coming to solar energy. Solar energy is a very large, inexhaustible source of energy. The power from the sun intercepted by the earth is approximately 1.8 into 10 power 11 megawatt, which is many thousands of times larger than the present consumption rate on the earth of all commercial energy sources. Thus, in principle, solar energy could supply all the present and future energy needs of the world on a continuing basis. This makes it one of the most promising of the unconventional energy sources. Solar energy is received in the form of radiation, can be converted directly or indirectly into other forms of energy such as heat and electricity. This energy is radiated by the sun as electromagnetic waves, of which 99% have wavelength in the range of 0.2 to 4 micrometers. Solar energy reaching the top of the Earth's atmosphere consists about 8% UV radiation, 46% of visible light, and 46% infrared radiation. Coming to classification of methods for solar energy utilization. Solar energy utilization has two types, that is direct method and indirect method. In direct method there are two types, namely thermal and photovoltaic. In indirect there are six types, namely water power, wind, biomass, wave energy, ocean thermal, and marine currents. Solar applications. Solar heating, solar cooling, solar pumping, solar furnace, solar production of hydrogen, solar greenhouses, solar distillation, solar energy, and solar cooking. Next, coming to photovoltaic, and it is also known as solar cell. It is a device that converts the solar energy into electric current using photoelectric effect. Photovoltaic power generation employs solar panels composed of number of solar cells containing photovoltaic material. Photovoltaics are made up of semiconductors and it converts solar radiation into direct current electricity. Coming to working of photovoltaic solar cell. Photovoltaic cell is made up of semiconductor material like silicon. One layer has N-type silicon and another layer has P-type silicon. An interface between N-type and P-type silicon is called p-n junction. In a p-n junction, semiconductor material electrons from N side tend to move towards P side rapidly combined with large number of hole concentration. Similarly, holes from P side tend to move towards N side rapidly combined with large number of electron concentration. This charge of distribution across the junction gives rise to electrical field. When a p-n junction semiconductor material exposed to the sunlight, some of the solar photons will have a tendency to dislodge free electrons from its fixed position in the material. Ejected free electrons tend to move towards P side and this flow negatively charged electrons constitute an electric current. Advantages of photovoltaic cell. Very little research money has been invested in the development of solar cell. It gives long duration period. Operating costs are extremely low compared to existing power technology. Applications. These solar cells are used to operate irrigation pumps, navigational signal, railroad crossing, to operate calculator and watches. Coming to water power, it is also known as hydropower. Power derived from the energy of falling water and running water which may be harnessed for useful purpose. In ancient years, hydropower has been used for irrigation and operation of various mechanical devices such as water mills, sawmills, textile mills, domestic lifts, powerhouse and paint making. Classification of hydropower. Conventional hydroelectric referring hydroelectric dams, run of the river hydroelectricity which captures the kinetic energy in rivers or streams without the use of dams. Small hydro projects are 10 megawatt or less and often have no artificial reservoirs. Micro hydro projects have a few kilowatt to a few hundred kilowatt, isolated homes, villages or small industry. Coming to wind energy. Energy of wind can be economically used for generation of electricity. Winds are caused from two main factors, heating and cooling of the atmosphere, which generates convection currents. Heating is caused by the absorption of solar energy on the Earth's surface and in the atmosphere. The rotation of the Earth with respect to atmosphere and its motion around the Sun. The energy available in the wind over the Earth's surface is estimated to be 1.6 into 10 power 7 megawatt. Wind energy, which is an indirect source of solar energy, conversion can be utilized to run windmill, which in turn drives a generator to produce electricity. The combination of wind turbine and generator is sometimes referred as aerogenerator. A step-up transmission is usually required to match the relatively slow speed of the wind rotor to the higher speed of the electric generator. Data quoted by some scientists for India, wind speed value lies between 5 km per hour to 15 to 20 km per hour. Wind farms are operating successfully and have already fed over 150 lakh units of electricity to the respective state grids. The power in wind. Wind possesses energy by virtue of its motion. There are three factors determine the output from a wind energy converter: wind speed, the cross-section of wind swept by rotor, and the overall conversion energy of the rotor, transmission system, and generator or pump. Only one-third amount of air is decelerating by the rotors and 60% of the available energy in wind into mechanical energy. Well-designed blades will typically extract 70% of theoretical max, but losses incurred in the gearbox, transmission system, and generator or pump could decrease the overall wind turbine efficiency to 35% or loss. The power in wind can be computed by using the concept of kinetics. The windmill works on the principle of converting kinetic energy to the wind to mechanical energy. Thank you.